Hello friends, my name is Harivir Singh and today I'll discuss simple truss analysis method of joints. So for this I have taken one problem. This is a kind of truss, simple truss. Simple truss is a truss which is made up of triangles only, like this 1, 2, 3 triangles. So for this we'll do our analysis, and that analysis part step by step procedure we'll discuss. So for this problem of truss, our first step is to draw the Freebody diagram. Support reactions, but not all the time, if necessary. When it is necessary, I'll let you know. In step 1, if you want to draw the Freebody diagram for this simple truss, what we can do, remove all the supports and show the support reaction there. So what you can do, at this point, it was a roller joint. So instead of roller joint, what we can do, we can apply one support reaction here, and that we can label as RB. As at joint A, it is a pin support. So what we can do, we can remove this pin support from here, and we can apply two reactions, RAY and RAX. As it is understood from this diagram that there is no external loading which is in X direction. So this reaction RAX is not necessary to mention here. If there is no external loading along X or inclined loading, then this is not necessary to show in the FBD, as it will automatically come equals to 0. Now if we apply equations of equilibrium to it, sigma Fx is equals to 0 should be our equation of equilibrium. Then plus, considering this rightward positive, plus RAX, and there is no other force to balance this, so this should be equals to 0. If we apply equilibrium equation in y direction, what we'll get? We'll get, considering upward positive, we'll get RAY minus 20 minus 40 plus RB is equals to 0. That makes it RAY plus RB is equals to 60 Newton. Now again, there are RAY and RB, two unknowns. I need one more equation. So that equation I can get from net moment. This moment can be taken about any point, but to make our analysis faster, we have to take moment about that point from which any unknown is passing. So in our case, there are so many points we can take moment about, but we have to take moment about either A or point B, because at A there is one unknown and at B there is one unknown. So if you take moment about A and B, we can directly get one unknown in one stroke. So we'll take up moment about point A, and this equation will give you, now moment about point A, we can write as 20 into 1 positive. Why positive? Because we are considering clockwise movement as positive. Now this 20 into 1, 20 is this force and it should be multiplied by 1. Why 1? Because the perpendicular distance from A to line of action of this 20 is 1, as this is an equilateral triangle, this AEC equilateral triangle, and this load is acting at a distance 1 meter from end A. So this should be like this, 20 into 1 clockwise. Then next force is this 40 Newton. And line of action of this 40 Newton force is at a distance of 3 meter from here. So I can write 40 into 3 clockwise. And this RB is at a distance 4 meter. And sense of rotation of this RB about point A is anti-clockwise. So we should put here negative sign. This should be equals to 0. Now, few of you may get confused that how I am taking this distance 1 and this distance 3. Because of symmetry we can take. Otherwise, if you want to check how you can check it, you can check it like this, that this is a right angle triangle as this side is 2 meter, this angle is 60, this angle is 60, this makes it equilateral triangle, and for equilateral triangle each side should be of 2 meters. So this side is 2 meter. Now how much this side should be from A to here? It should be the cos component of 2 cos 30. It should be 2 cos 30. So that 2 cos 30 makes it 1 only. So like this we have completed our equation, and from here we will get the values for reactions, and those values are RB is equals to 35 and RA 60 minus 35, it should be equals to 25 Newton obviously. Now after this first step, what we need to do? Step 2, look for the joint having minimum number of unknown forces. Now in our case we have 5 joints, and from those 5 joints we can see that at joint C, D, we have 1, 2, 3, 3 unknowns. At joint E, at present scenario, at joint E, we have 1, 2, 3, 4 unknowns. At joint A and B, we have only 2 unknowns. So we should start our analysis either from A joint, either from B joint. Don't get confused, because A is having 1, 2, 3, 4. Out of this 2 you have already calculated. RA X should be equals to 0, RA Y should be equals to 25 Newton. So these you have already calculated. So there are only 2 unknowns left. Now after identifying the joints which are having minimum unknowns, we should start our analysis with those joints. Now step 3 is to draw free body diagram of pin. As you know that it is our preliminary assumption that each joint is connected with the help of a pin. So that pin we can draw the free body diagram and assume all the unknown forces of tensile nature. If you don't know the actual nature of force, by observation you cannot predict, then you should assume that all the unknown forces are of tensile nature. If your answer comes as positive, that means your assumption is correct, whatever you have assumed. And if your answer comes negative, that means the assumptions is not correct and the actual force in that member should be of compressive nature. If your answer comes negative, if it is positive, then whatever we have assumed that force in that member is of tensile nature, that assumption is. Let us take up this step 3 here. I will draw the free body diagram of joint B. PD of pin at. So for this what we need to do, at this pin we need to mention this pin. Then draw horizontal and vertical reactions, vertical lines passing through it, and mention all the forces which are acting. So we know that RB is of 25 Newton. It is acting on the pin like this. It is acting on the pin. Now BD and EB, we don't know the direction of force. Whether it is tensile or compressive, we don't know. So we will assume that the forces are of tensile nature. Tensile forces we should always mention away from the pin. So we can draw a force like this. This force is nothing but FBD, and this force I can draw like this, that is force in member BE. Now angle between these two is, after this what you can do, step 4 is to draw. Now step 4 is to apply equations of equilibrium for the joint for which we have drawn the free body diagram. In our case, joint B. For this, in step 3 we have drawn this free body diagram. Now we have to apply equations of equilibrium for this. Apply equations of equilibrium. First we can do that this FBD we can resolve. The forces along X and Y, we'll resolve it here. It was given like this. This force was 25 Newton. This FBE is already horizontal force in member VE. Now, this FBD can be resolved along X and Y axis. So what we can do here, this force we can mention as FBD cos 60, and this force we can do as FBD sin 60. Now all the forces are being resolved along X and Y axis, and then we can apply equations of equilibrium. So equations of equilibrium for a pin, net force along X direction should be equals to 0. This will give, considering rightward positive, this will give minus FBE minus FBD cos 60 is equals to 0. It also means that FBE is equals to minus FBD cos 60 means half. This is your one equation. And then we can apply equations of equilibrium for net forces along Y direction. So considering this upward direction as positive, we can apply this, and then we'll get plus FBD sin 60 plus 25 is equals to 0. So from here you will get FBD is equals to minus 25 by sin 60. That is minus 28.867 Newton. Now, this minus sign indicates that we have assumed it was tensile, but it indicates that this force is of compressive nature. So this FBD is equals to 28.867 compressive. Now, putting this value FBD in the equation 1, we'll get that force in member BE is equals to, now put it with this negative sign, minus 28.867 by 2. So that will make it FBE is equals to 14.43 Newton. Now this answer is coming as positive. So that means whatever we have assumed that FBE is of tensile nature, that assumption is correct. This force actually is of tensile nature. So like this, now we have solved the FBD and FBE forces developed in these two members. Now what we can do, like in these members we have solved. Now, if you look at joint D now, pin at D. Now how many unknowns this have? Earlier it was having 3 unknowns, but as we have solved for force in member DB, now it is having only 2 unknowns. So we can extend our analysis to point D, and like this we can solve for members this CD and DE. Now, if we have solved for this, what we can do? Now look at this E. Earlier this E was having 4 unknowns, but after solving these two joints, this is having only 2 unknowns. So we can extend our analysis further to joint E or joint C also, because now joint C is also having only 2 unknowns. So like this, we can get the values of forces in all the members of the truss. Like this, we can get the values of unknown forces in all the members of truss by moving on to joints. Now we have one gate problem in which 2-member truss is shown in figure and the force in member AB is to be determined by us. How much force will be transmitted to this member AB? Now for this, how we can approach? Step 1. As I told you that it is not necessary always to find support reactions. So in this particular problem, as it is of only 2 members truss, no need to solve for support reaction. So we can definitely skip this support reaction part. Skip support reaction because those are not required. Now, part second is, step 2 is to look for joint having minimum number of unknown. So obviously here only joint B we need to study because it is having only 2 unknowns and out of which only 1 is being asked from us. So in step 2, our joint is B. For this we have to draw the free body diagram in step 3. So now step 3 is to draw the free body diagram. Free body diagram for this pin at B. FBD for pin at B we can draw. So for this, first locate the pin. Here I will do this. First locate the pin. This is your pin at B. Then draw the axis. This is your x-axis, this is your y-axis. Now you mention the forces acting on it. So this was one force, 10 kilonewton. Other forces, you don't know the actual direction of them, so assume them to be tensile in nature, force in member AB, and this is force in member CB. Now the angle between these two can be assumed as theta, but with the help of geometry we can definitely find this theta. Why? Because this height is 0.5 meter, this is 1 meter. If you assume this angle is to be theta, we can always write tan theta is equals to height upon base 0.5 upon 1, that is 1 by 2, and theta can be written as 26.565 degrees. Now, after drawing this free body diagram, step 4 is to resolve the forces along x and y and apply equations of equilibrium for a particle. So this part how we can do? After drawing this free body diagram, we need to resolve the forces along x and y and apply the equations of equilibrium. So resolution part we can do like this. We have this force FAB. We have this force 10 kilonewton. Now this FCB part can be resolved and we will have FCB cos theta, and we will have this FCB sin theta. Now these are along y-axis and x-axis. This is the resolution part at joint B only. Now we apply equations of equilibrium for this. So let us take sigma Fy is equals to 0. Then we will consider it as positive upward, we'll get minus 10 minus FCB sin theta is equals to 0. So from here you will get as FCB is equals to minus 10 upon sin theta. You got one value. Now apply equations of equilibrium. Sigma Fx is equals to 0. Considering right word as positive, you will get minus FAB minus FCB cos theta is equals to 0. Now what you can do, you can put the value of FCB from this equation to in this equation. So after putting that, you will get as, I will write it here, you will get as FAB is equals to minus 10 upon sin theta into cos theta. So minus will make it plus. Sin theta upon cos theta, we will have tan theta, and that is 0.5. Directly it can be written as 0.5. So FAB can be written as 10 upon tan theta. And tan theta is nothing but 0.5. So your answer for this becomes FAB is equals to 20 kilonewton. In the problem, only magnitude was asked. So this is 20 kilonewton. If direction is to be determined, how to get the direction, obviously it is coming out to be positive. That means we have assumed earlier that FAB is of tensile nature, so that is correct assumption. This force is of tensile nature. So thank you.